Hello everyone, welcome to my presentation. I'm Solmaz and I'm going to present our paper called Complementing Educational Recommender Systems with Open Learner Models. I'm PhD student at the University of Queensland and did this work with my PhD advisors, Dr. Hassan Khosravi and Professor Shazia Sadiq and also Professor Dragan Gazovic. Here is an overview of my presentation. It starts with an introduction to the problem, followed by the method that we use in our study, and then the results of our study. Finally, I will present the conclusions and future plans for my study. As we are all aware, nowadays educators continue to face significant challenges in providing high-quality post-secondary instructions in large classes. A significant portion of these challenges emerges from high levels of diversity in students' academic ability. So educational environments continue to rapidly evolve to address the learning needs of this diverse growing population. But to be able to survive in these learning environments, students need to be able to identify the characteristics of learning resources that will be best, most interesting, and most beneficial for their learning. But current literature on students' learning behavior indicates that students often lack the required skill and expertise on making proper decisions on what and how to study by their own. Educational recommender systems offers a potential solution to this problem by providing a personalized learning experience for students. In the educational settings, researchers have tailored exemplary techniques from recommender systems to adaptively recommend a broad range of resources such as learning activities and videos to students that will best meet their learning needs. To provide such adaptivity, the recommender systems relies heavily on a component called learner model, which is a common component in many educational systems, not the adaptive ones. Learner models captures an abstract representation of a student's ability and behavior based on their performance and interaction with an educational system. But the challenge is that commonly in educational recommender system, the learner model is not shared with the student. So from a student's perspective, the recommender system operates as black box and gives users no insight into the rationale of the recommendations. The black box recommendations, which is also a common issue in other contexts as well, can lead to trust issues, especially when users do not agree with the result of recommender systems. And it seems in particular inadequate for educational settings where educators strive to enable their students to develop their reasoning and understanding. Here is an example of an recommendations without justification, that the result of recommendation is just presented to students as a list of recommendations. In recent years, researchers from different contexts, such as critiquing-based recommendations, art recommendations, or music recommendation or social recommendations, they have hardly tried to address the black box issue of recommender systems. And they have used a variety of approaches to open the underlying reasoning behind that recommendations using different approaches such as simple textual interfaces to more complicated interactive visualizations. And the findings of these researchers suggest that making the recommender systems more transparent help students to feel a greater control over the recommendation problems and increases the trust and acceptance of the recommendations. On the other hand, in a separate body of research and in the educational context, researchers have studied the development of approaches that can assist students in better understanding of how their learning is captured in the educational settings, which is commonly referred to as open learner models. Open learner models are the learner models that are externalized and made accessible to students or other stakeholders, often through visualization as an important means for supporting learning. And they have been integrated into a variety of applications, such as learning analytics dashboard, intelligent tutoring systems, or adaptive learning platform. These are some examples of the work that have been done. These books have tried to open the reasoning behind the learner model using different visualization, ranging from simple skill meters to more complicated concept maps or hierarchical tree structures. And the findings of these studies have framed the benefits of OLM mostly around promoting metacognitive activities for students, such as reflection, planning, or self-regulation. Upon a close investigation of the literature, We identified that while the black box issue of recommendations has been widely studied in different contexts, the impact of providing transparent recommendations has not been studied for educational recommender system. On the other hand, OLMs have been widely studied in the educational settings, but independent of educational recommender systems. So in this paper, we aim to investigate the impact of complementing educational recommender systems with transparent and understandable OLMs that provide justification for the recommendations. Our investigations were guided by two research questions. How does complementing an educational recommender systems with the visualization of an open learner model impact the students' engagement with the system? How does complementing an educational recommender systems with the visualization of an open learner model impact the students' perceived effectiveness of the system? To answer the two research questions that I just introduced, we conducted a control study using an adaptive learning system called Ripple. Ripple is a content agnostic adaptive learning system that uses crowdsourcing for the development of learning resources. In its current version, Ripple uses a learner model that estimates a student's knowledge state based on their performance on attempting learning resources. The findings of the learner model is then used by the recommender system of the system to recommend personalized learning resources to students. If you are more interested to learn more about Ripple, you can visit ripplelearning.org. For this study, we used two interfaces of one of the main pages of Ripple called Practice that allows the students to access the available resources based on search and recommendation functionalities. Oh, okay. It seems that people cannot hear the video, so I would explain it again. This figure shows the interface of uh, uh, is the first interface that we use is the non-complemented interface. At the top, it has a set of filters that allow students to get access to the resources based on a set of options such as recommendations or the effectiveness. And at the bottom, we can see the recommendations are presented to students as a list of learning activity cards. Each learning activity card includes an overview of the learning content, the concepts that are associated with that learning activity, and a sidebar that gives some information about that learning activity. This figure shows the second interface of Ripple, in which recommendations are coupled with the visualization of the learner model. At the top section of this figure, we can see an interactive visualization widget that enables the students to see an abstract representation of their knowledge state. It shows a student's knowledge state based on three colors, which is determined by the underlying learner model. Red shows inadequate competency. Yellow shows competency but rooms for improvement, and blue shows enough competency. And the top and the bottom section of this interface is again exactly the same as the first interface. Upon attempting each learning activity, the learner model updates the student's knowledge state, which is also reflected on the findings of the learner model, open learner model on a real-time basis. So for this study, we used Ripple in an on-campus course at the University of Queensland, in which the 50 students that participated in our study made more than 2,000 attempts on 280 learning activities that were available in the repository of the system. For this study, we adopted a between-subject experimental design where our students were randomly assigned to one of the two conditions. The independent variable of our study was whether students using the complemented interface or non-complemented interface. And the dependent variable of our study was the students' engagement with the recommender system and the responses to a set of survey questions. For statistical analysis, we used Mann-Whitney U-test. But the problem is that using randomized controlled trial in education is always subject to ethical issues. While randomized controlled trial is the golden standard for establishing causality in many fields, in education it's debatable because it can disadvantage a group of students. To alleviate these issues, we had a set of considerations before conducting our study. That we first gathered students' consent form, and then engagement with Ripple was not tied to a student's assessment in any way. The scope of our study was around engagement and perception about the platform rather than the learning gains. And we ran the study for the duration of the 5 weeks. To answer the first research questions, we used students' interaction logs and considered 3 objective measures: the average number of attempted activities by students, the average of total session time for students, and the average of each recommendation session time. As it is indicated here, with regards to average number of activities, students who use the complemented interface attempted more learning activities compared to students who use the non-complemented interface. And it happens for the total session time that the students who use the complemented interface had a longer total session time compared to students who use the non-complemented interface. And more significantly, students who use the complemented interface had significantly higher recommendation session time during each session of recommendations compared to students who had use non-complemented interface. To answer the second research questions, we asked the students' perception based on using a survey based on a set of statements that are presented here. They were mostly around understanding the rationale behind recommendations, trust in the recommender system, or easiness of the system and acceptance of the system. If I want to point to some of the main findings of this survey, I can say that students who use the complemented interface reported significantly higher confidence in the method used by Ripple in estimating their knowledge state, and that they had significantly higher confidence in Ripple to correctly adopt its recommendations on the basis of their current knowledge needs. Interestingly, students who use the complemented interface reported that Ripple is harder to navigate, and we speculate that it's because of the addition of that OLM that adds complexity to the system, which makes it harder for students to understand their OLM itself. In our paper, we also reflected on some insights and lessons learned that we learned from running the complemented interface of Ripple in 15 courses over 3,000 registered users. And the source of our data was the surveys that were conducted, feedback forms, discussion forums, and focus groups and usability studies. By and large, students provided positive feedback about the integration of OLM into Ripple. However, we also identified some challenges and drawbacks that I would share it with you. By and large, students mentioned that the addition of OLM helped them to understand the rationale behind recommendations, but we identified that this addition has created a new problem for some students, that how is OLM precisely showing and how is my competency is approximated by the learner model. So one way that we try to address this issue was to add some tutorials or hints on the platform to explain that how a learner model or OLM is really works. The second problem was that on average, students mentioned that they have trust in RIPL to fairly estimate their knowledge state. But we also identified that sometimes this integration of OLM into ERS acts as a source of, increases the sense of unfairness for some students. And it specifically happens in two cases: when a student with high competency rating answers an easy question incorrectly, or students perceive a question to be incorrect, but to be of poor quality and answers it incorrectly. One potential solution for this problem is to make the open learner model negotiable, that allows the students to negotiate with the system about the learner model. And it's a well-established research field in the open learner models. The second problem was that by and large, the students mentioned that the integration of that open learner model into educational recommender systems increased their engagement with the system because they wanted to attempt more learning resources to increase their rating. But we also identified that it can act as a source of disengagement for some students as well. And it happens because the students are so stick to their rating. So sometimes they avoid to engage with challenging learning resources because they are afraid of losing their ratings. And based on the suggestions from some students, we plan to add a practice space in RIPL, which the results of these practices are decoupled from the students' OLMs. So in conclusion, we expect that the recommender systems should enormously benefit from the open learner model, from the integration of the open learner model. And indeed, the result of our controlled study indicated that complementing educational recommender system with open learner models provides students with a better sense of their learning, enhances their engagement and perception of the effectiveness of educational recommender systems. However, in practice, there might be some drawbacks, as I just mentioned them. Therefore, we think that integration of open learner models into educational recommender systems and more broadly educational technology need to be done with care, providing that we have students with sufficient digital literacy to understand the visualization of OLMs. We provide sufficient information and transparency about how OLM approximates a student's ability. We provide mechanisms for students to voice their disagreement about the abstract of their OLMs, and a safe space for students to practice without being concerned about the hit to their learning. And in the future, we plan to evaluate the generalizability of our current findings using a bigger population of students, and also investigating how open learner models can more effectively be integrated into educational recommender systems. Thanks for listening.